So if you notice it, in last class, as I told you, we have two kinds of motors. One is the DC motors and another one is AC motors. So now if you notice it, in last class, what we studied is a simple motor actually. That is only we used to say a DC motor. So it's not having much complexity, and as well as not having more number of coils and more number of turns and all. So only having a simple structure inside, how the motor will works, a simple motor, or we can say even DC motor it is. So a simple motor always will works, as we know the principle called as a Fleming's left hand thumb rule. Yes or no? So Fleming's left hand thumb rule. So we are having a three fingers we will use to take always. So the middle finger is always indicating which finger, what is that guys? Direction of current. And forefinger, this index finger we used to say, it is indicating always the direction of magnetic field, and the thumb is indicating always the magnetic force. Yes. And as we know that this magnetic force depends on three factors. One is amount of magnetic field, means the strength of the magnet, and the next one is amount of current, and as well as the length of the conductor. So if you notice it, these are the three things, and as well as one more thing, we know that angle between them is always they are perpendicular to each other. That is what? 90 degrees. So if the angle becomes 0, then the force will become 0. If angle become 90 degrees, then the force will become B into I into L. So these are all the things we already discussed. The force will become maximum when angle become 90, or we can say perpendicular. Yes or no guys? Please respond. So now if you notice it, your textbook also if you see, after electric motor, if you note, this is what we used to say a simple motor, or we can say DC motor structure, which we have been studied in the last class. So now if you see, generally if we are using in our home and all, so usually these DC motors are simple motors we will use for science exhibitions or any kind of experiments, small experiments and all, like what you have been done under the physics multidisciplinary activity or something you people made correct. So that is what we used to say DC motors. Very small level applications we will use it anywhere we are having, like even for example, if you see like a small running fans, small fans, if you want to run or in experiments and all, if you want to blow the bulbs and somewhere, if you want to use it in a small science experiments and all, we will use this DC motors. But if it comes to the commercial purpose, so as we know, we are always having commercial units also. If you notice it, last electricity chapter also, we people have studied a general unit of energy, which is joule, and the commercial unit of energy, if you notice it, what is the commercial unit of energy? Kilowatt hour, or we can say units. Is it yes or no, guys? Please respond. And as well as we know that 1 kilowatt hour, which is equals to 3.6 into 10 power 6 joules. These are all the things we studied in the last chapter. Yes or no? Please respond. Yes. Same way here also. Commercial unit means where we are using in our household purposes and as well as industrial purposes. So that is the industrial and household purposes only we used to call it as a commercial purpose. So if it comes to the commercial purpose, we are using these motors, not simple motors, commercial motors we used to call it as like AC motors, very, very big in size. So we are using in our agricultural lands, in our home to pump the water, and so many places wherever you are having running different equipments, motors and all, we are using these commercial motors only. So these commercial motors is different from simple motor. So why it is and how it is, let us discuss. So now if you notice it, everybody, so commercial motors, it is needs to work with very high and as well as low currents and as well as high currents. So the current will be varies. So as I told you, so now you people tell me, actually 3 points are there. So let it be, we have to increase the magnetism. So we have to increase the magnetism so that we will place some material inside these coils. What is that material? Already I taught you electromagnets and all. Can anyone say? Now commercial motors having three more like features. We'll define the simple motor and commercial motor. So now this commercial motors contains different things compared to the simple motor. So that is only. So to increase the magnetism, we'll place some material in the coil. Like solenoid also, if you'll notice it, we'll place some material to increase the magnetism. What is that? Please respond.
Soft iron, sir. Soft iron.
Very good, Arvind. Soft iron. So that is the first thing. So if we'll take the commercial motors, the coil is wound on a soft iron core. Do you understand? So whatever the coil we are making, it is wound on soft iron core so that the soft iron core becomes magnetized and increase the strength of the magnetic field. Do you understand? So if the strength of the magnetic field is increases, what is happening? That will make the motor more and more powerful. So the assembly of soft iron core and the coil, that is only ways to called as armature. Do you understand, everybody? So the soft iron and wounding that insulated copper wire, that is only that full assembly, that arrangement of that in the inside the motor is only ways to called as armature. Very, very important. So now next, these coils, if you'll see, they contains very, 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 very large number of turns of insulated copper wire. So that as we know that more number of turns, more the length of the conductor is keep on increases, so that the strength of the magnetism will be increases, so that the power of the magnet will increases. And also you can see, so we will prefer in the commercial motors electric like permanent magnet or electromagnet. Anybody? Which magnet will prefer? Either permanent magnet or electromagnet. Anybody? Sanjay? Aishwarya? Which magnet will prefer in these commercial motors? Permanent magnet or electromagnet? So as I already told you the differences between permanent magnet and electromagnet. Permanent magnet is having a fixed magnetism, so that whenever we need to increase, we cannot increase. Whenever we need to decrease, we cannot decrease. But if you use electromagnet, what will happen? We can control the amount of magnetism. So now you tell me, commercial motors, which one we can use?
Electromagnet.
Electromagnet. That is the point which you have to remember. So the powerful electromagnet is used in place of permanent magnet. So these all the features which is together to help in increase the power of commercial electric motors. So we need more power, more strength of these electric motors, commercial electric motors. So that is why all these three features we will add it. So if you notice it, in sometimes rarely exam they will ask you what is the difference between normal motor and electric motor, this commercial motors. By the time you have to write it. And main thing, what is armature they will ask. So by the time is compulsory you have to write what is armature. So what is armature, guys? So the assembly of soft iron core and coil which is wounded, that is only the setup only ways to called as armature. So now if you notice it, even textbook also they have given, but you might be not notice. So all of you open page number 233. All of you open page number 233. If you'll see last 3 points, you can notice it. The commercial motors use after the paragraph, the rotation of the coil and the axle only shaft we can say. Yes or no, guys? So after that, they have given that, correct? So that 3 point from there, the commercial motors to end, everybody should learn it. I don't want to waste time with writing. So now you have to practice it and you have to understand what it is. Okay, Krutika? Just call your friends, everybody, please. So that is what you need to remember. So the commercial motors use, so they are having 3 different things. All the features will help to increase the power of the commercial motors. That is what you have to understand. Is it okay, guys? Everybody, please check it, all of you. Is it fine? Yes? Arvind? So that is everybody need to understand. So now if you understand this, then we people will go to the next very important concept. Today I will give you the introduction of that concept. So that is only, so that that commercial motors, everybody you have to learn it. What is armature? Because armature is the important one. So sometimes they will ask you armature. That is why. Varshini, have you understand, Varshini? So what is the three things which is different from the normal motor? Three things. One is the soft iron is kept inside the wounded copper wire so that the magnetism will increase. The second one is what, guys? What is the second one? If you are not speaking, then what is the second one? It contains a large number of turns, okay, of the insulated copper wire. And next one, a powerful electromagnet is used in place of permanent magnet. So these are the three features which is all together will help in increasing the power of a commercial motors, which we have been remember, which will make the separate from the general motors. So now if we'll see, the next concept is more important for final exam, and definitely the questions used to come from this is only. So now electromagnetic induction or electricity from magnetism. So that is what we are going to study. So all of you remember, hope your textbook also, if you see, the next concept is magnetic induction or electromagnetic induction. Yes or no, guys? Please respond. Yes. So electromagnetic induction. So what do you mean by electromagnetic induction? Simple meaning, if you want to know, that is electricity from magnetism. That is only ways to call it as electromagnetism. Understand? So electromagnetic induction. So generating electricity from the magnetism is only called as electromagnetism. So we can generate the electricity with the different ways. So that is also we'll study. With the help of magnet, we will study, we will generate electricity. With the help of electricity also, we can generate the electricity. That is all in detail we'll study. But here, more number of confusions, more number of directions, left, right, stagnant, like that, lot of things will come. So first of all, everyone try to understand what is electromagnetism. So electromagnetic induction. And later we can understand what it is. So now here, scientist names also have to remember, because these phenomena and all very, very important. So if we'll see here, electromagnetic induction means, simply I can say electricity from magnetism. Means from the magnetism I am generating electricity. So till now what we studied, generating magnetism from electricity. Now electricity from magnetism. So that is only called as magnetic induction. So now if you see, electric current can produce magnetism. That is what till now we discussed. So wherever the current carrying conductor, when the current is passing across the current carrying conductor, everywhere it is showing some force of attraction, some influence on its surroundings. So that is only magnetism ways to say. So now the reverse of this, that is what? Electricity generating magnetism, and magnetism will generate electricity. So that is only ways to say it is reverse of this is also true. So now the magnetism can produce electric current. So the production of electricity from magnetism is only called as electromagnetic induction. So let us take some examples to understand this. So try to see when the situation will come, I will explain like with a diagram. So this is all like something theory you should understand about this. What is electromagnetic induction, and as well as who is the scientist who has been discovered this and all. That is one. So if we take for example, let me consider when a straight wire. You all know that a straight conductor. So let me consider this is my straight conductor. So when a straight conductor is moved up and down rapidly between the poles of a horseshoe magnet or U-shaped magnet. Let me imagine my hand. Do you understand, everybody? So this is what my horseshoe magnet. All of you can understand. So as we know that when it will generate electricity or whatever it is, force is maximum when it is perpendicularly to each other. Yes or no, guys? When the direction of magnetism is acting like this, the conductor should be placed perpendicularly. So now, if I am moving this conductor to and fro motion very fastly between the poles of the horseshoe magnet or U-shaped magnet, and if this conductor is connected to a galvanometer. So as we already taught you the electricity chapter, galvanometer. So galvanometer is a device which will use to measure very low currents, and even small currents also it can detect in the given circuit, and as well as it will find the direction of the current also. So that is why instead of ammeters, we will use galvanometers. So ammeter only measures the amount of current, and galvanometer will also gives you the direction. So that is why we will prefer always galvanometer. So now in this, what we'll do again, this activity also will do it, and I will show you with the practically also that diagram based. So now if you'll notice it, let me take, this is my horseshoe magnet, you all will notice. So let me imagine this is a north pole and this is the south pole. So now as we know, north pole to south pole, the magnetism is always passing. So now when a straight wire is moved up and down rapidly like this, to and from motion, if I keep on doing, relative motion, we can say, rapidly between the two poles of a horseshoe magnet, then you can see electric current is generated or produced in this wire. So if you have been connected to the galvanometer, so galvanometer is keep on deflecting. If it is keep on deflecting means in the sense of what? It is electricity is generating. That is what you have to understand. So that is the simple example of electromagnetic induction. So or else you can take, sir, I don't want that. Let me take now bar magnet. So these two experiments I will teach you. So but textbook they have given only single experiment, but any experiment we can do. And remember, so electric motor we have been used a law called as, what is that, guys? Fleming's left hand thumb rule. Yes or no? But here we will use induction. Whenever you will get a induction word, remember we are going to use Fleming's right hand thumb rule. Okay. So this Fleming's right hand thumb rule only we will use it for induced current and as well as electric generator, but electric generator is deleted for us, but still the Fleming's right hand thumb rule we will start. So now this is the first example. When a straight conductor is moving between the poles of a horseshoe magnet, then it will generate the electricity. Current is produced in the wire. So that is the example of electromagnetic induction. Or you can take one more experiment. That is what we all know that. If you take a solenoid, so solenoid means what, guys? The wounded wire. Yes or no? So solenoid, if you take, let me imagine like this solenoid, then if you move, a bar magnet is moved in and out of the coil of a wire like this. And this coil is connected towards to the galvanometer. That is what they have given in our textbook also. The picture number next 13.11, I think. 13.11. All of you check it. So one solenoid I will take and I will move the bar magnet. I'm not saying any pole. Later we'll study the poles. If I keep on moving the bar magnet in and out, relative motion of the coil wire, then the electric current is produced in this coil. So that is also example of electromagnetic induction. Do you understand, everybody? Or else I have fixed a bar magnet. Like imagine this is my bar magnet and this is my coil. Now coil is moving to and from motion, like this to and from relative motion coming out, understand, moved in and out. Then also we can observe the electricity is generated in the coil. So that is also example of what, guys? That is also example of electromagnetic induction. So what is that? Either a straight conductor is moved between the two poles of a horseshoe magnet or U-shaped magnet to and from motion, up and down. Then also in this conductor, electricity is generated. Or else a bar magnet is moved inside the coil, in and out. Or else the bar magnet is fixed, the coil is moving in and out. Then it is also will produces a electricity in the coil. So these are the things we can say are the examples of electromagnetic induction. Remember, electromagnetic induction means electricity from magnetism. With the help of magnetism, we are generating electricity. So now, let us take the current produced by a moving a straight wire in a magnetic field is only called as induced current. Whatever the current is producing because of movement of the wire or because of movement of the bar magnet in and out of a solenoid. So because of the movement of this, either conductor or magnet, so whatever the current is producing, that current is called as induced current. And the phenomena of this electromagnetic induction was discovered by first a British scientist named called as Michael Faraday. Please, all of you remember. So that is why we can study Faraday's laws also. Very, very important. So Michael Faraday, and he is an American scientist, and he is the one more American scientist, Henry also, Joseph Henry. They are separate. It's not together. Independently in 1931, they have been discovered this. Understand? So two scientists. One is electromagnetic induction is discovered by a British scientist Michael Faraday and an American scientist Joseph Henry, independently in 1831. Okay. So now this process of electromagnetic induction has to lead the construction of generators for producing electricity at power stations. That is why the principle which is behind the electric generators is electromagnetic induction. Understand? So with the help of electromagnetic induction only, the electricity is generated at the power stations or generators, electric generators, which you are having during power cut time. People will use generators, correct? So the generators will work with the principle of electromagnetic induction only. So once after this discovery by Michael Faraday and Joseph Henry only, it leads to the manufacture of or development of a new instrument called as electric generator. Okay. So now, before we describe to demonstrate this phenomena of electromagnetic induction, first we should know a very in detail thing about this galvanometer, as I told you. So galvanometer is an instrument, all of you remember, which can detect the presence of electric current in a circuit. Now, if you want to see the galvanometer practically, so now in our picture, in our group, I will send you one picture. So please, all of you open that and you can see. So that is what the example of a galvanometer. So I will send you. So now that is the real galvanometer, but its direction I marked it wrongly. So now we can modify it. So just all of you check it in our picture, in our group. So that is only we used to call it as galvanometer. So galvanometer is having like, we can say, all of you check it guys, everybody. So galvanometer always be like ammeter. Ammeter, how we have to connect? Nidinath, anybody? How ammeter is connected in a circuit? Sanjay? Ammeter, how we have to connect? Ammeter. Voltmeter and ammeter, you might be remember. So ammeter, we have to connect always in a series connection. And as well as voltmeter, always we have to connect in a parallel connection. Yes or no? So same way, if we take now galvanometer also, so it is a current measuring device and which is also need to connect always in series connection to measure the current. Do you understand everyone? So now if you notice it, how it will be present means, I have sent you the picture. Have you seen guys? Please respond. So these galvanometer, so now if you see, it will be showing the direction always. So that is the reason we are using, and also it will measure very low currents also. So it is varies. You can see the galvanometer which I have sent, maximum 30 milliamperes. That is the current. 30 milliamperes it has been. So now if you'll notice it, middle it is having 0. Now if you'll come to this side, it is used to measure 10, 20 and 30. Same way if you'll move to this side also, it is having 10, 20, 30. That is. So now all of you remember, now itself I am saying you. So galvanometer, how to measure this galvanometer? All of you see the directions because this is very important. So now if you notice it, whatever you have right side in front of you, so you are seeing my screen, your side it is opposite. So whatever you are seeing right side, so that this is my hand, I have a right side, this is, so this is what right side in a galvanometer, all of you remember. So this is only we used to say right. And if you notice it, this is what we used to call as left. Is it okay, guys? Everybody? Yes, please respond. So this is thing you have to remember in galvanometer. So galvanometer, either it will be deflecting towards to the right or deflecting towards the left. Now here I will say the least count also. So all of you, if you open the mouth only, I can at least I can able to guide you something. So all of you count the lines between 0 to 10. 0 to 10. Anybody? 0 to 10, how many lines are there? Count it. It is similar to our scale. Yes or no, guys? So here galvanometer measurements are how to measure. We must know least count. All of you remember. So how to measure the current produced with the help of galvanometer? Anything, ammeter, voltmeter, whatever it is, we must know least count. That is only we used to call it as LC. Understand everyone? So least count means, all of you remember. So the maximum current here, how much guys? 30 milliamperes, yes or no, divided by the total number of divisions. So total number of divisions means any one side only have to take, this side or this side. So total number of divisions from here to here. Check it guys, everybody. How many divisions are there? Each divisions, total number of divisions. Nobody cannot see. I have sent you the picture card. It will be each one 10 divisions will be there. So 30 divisions are. So each line is indicating 30, 30 will get cancelled. So the least count of this galvanometer is 1 milliampere. Understand? So if it is galvanometer is deflecting one line, so it is indicating 1 milliampere. If it is indicating 5, then 5 milliamperes is the current. If it is showing the 10, then 10 milliamperes is the current. So least count will find like this only. The maximum range divided by total number of divisions. That is only least count. Remember, maximum given range given divided by total number of divisions. Okay, total divisions. But here total divisions means don't take left and right both the sides, only one. But here the galvanometer will measure the directions. That is why they have given both left and right. Understand everybody? Please respond. This is only the least count. So least count we should know. So this is what we used to solve as galvanometer. So which we use to measure the current. And you can remember it is always connected in the series connection with the circuit. When no current is flowing, then the the galvanometer needle will be at the 0. All of you should remember. No current is flowing. Okay, then the galvanometer needle will be at the 0. Understand? And the pointer at the 0 mark is always, remember, it is at the center of the semicircular scale. When electric current is passed through the galvanometer, then it will be deflects or moves either towards the left side or towards the right side. And you remember, left side of 0 mark or to the right side of 0 mark, then it is depending on the direction of current. So that is the things you have to remember. If no current is produced, then the galvanometer needle will be at the 0. If it is current is produced, it means either towards the left or right based upon the direction of current, it will be deflecting. So that is what is galvanometer and what is electromagnetic induction. Now we will study the experiment to study the electromagnetic induction. So now hope you all understand. Any doubt guys, please respond. So what is electromagnetic induction? Electromagnetic induction means production of electricity from magnetism is only called as electromagnetic induction. So now the process of this electromagnetic induction, it is only leads to the construction of generators for producing electricity. It has been discovered by two scientists. One is Michael Faraday and second one is Joseph Henry in the year of 1831. And this induced current, what is induced current? When a current is produced because of a straight wire is moved, understanding, in a magnetic field or moving a magnet in a coil, whatever it is, both, anything. Either coil is moved in a magnet or magnet is moved, understanding, inside a coil, or a straight conductor is moved between the two poles of horseshoe magnet. Everything, it will produce the current. That current only we used to call as induced current. Understand? So these are the things you have to remember. Till here, any doubt, anybody, please kindly ask. Any doubt, guys? Please respond. Arvind, Karthikeyan, Prutiga.
No, sir.
So now, if you'll understand, so please write the definitions alone. So later for our today's class, we'll study the first experiment so that we can understand. So please all of you write electromagnetic induction. So electromagnetic induction also we can call it as what, guys? Electricity from magnetism. Electricity from magnetism. Electricity from magnetism. Electricity from magnetism. Right. Definition first. Definition. The production of electricity from magnetism. The production of electricity from magnetism. The production of electricity from magnetism. The production of electricity from magnetism The production of electricity from magnetism is known as electromagnetic induction. Electromagnetic induction. So examples, will you remember, guys? Either straight conductor is moving between the horseshoe magnets, or a bar magnet is moved inside a coil, or coil is moving, coming forward and going backward on the fixed bar magnet. That is what you have to remember. So everything. Next, induced current. Induced current. Anybody is having doubt, you can ask me. Padmashni, are you clear? Sanjay? Sriya? That is induced current. The current produced by moving straight wire in a magnetic field, or by moving a magnet in a coil, is called induced current. Is called induced current, and scientists and all, you people remember. Okay, now galvanometer, you have to remember, when it will deflect, if current is passed, either it will be deflecting towards the left or right based upon the direction of current. And galvanometer, if no current is produced, it will be always pointer at the 0 mark. So it is indicating no current is producing in that. That is what you have to remember. So now, if it comes to here, the first experiment which we are going to study under this electromagnetic induction is this one. That is what? A straight conductor. Understand? A demonstrating of electromagnetic induction by using a straight conductor wire and a horseshoe type magnet. So as I told you, horseshoe magnet, and the conductor is moving between the poles of horseshoe magnet. Then let us see how the current is produced and how the direction of current is also. We can move either moving downwards and going upwards. Okay, so shall we start, guys? So please all of you keep deciding. So here only we will demonstrate this one with the help of Fleming's right hand thumb rule. So once this concept is over, then only I will use the rule and I will teach you how the 3 fingers of Fleming's right hand thumb rule, we will use it to find the direction of current and as well as magnetism and force and everything. So let's start, guys. Yes. So now for these 2 things we need. What is the 2 things? Anybody? What is the 2 things? To demonstrate this activity, we need 2 things. One is what? One is a horseshoe magnet, understand? And as well as a straight conductor you can take, which is a AB insulated copper wire, which is attached to the galvanometer. So that is what we have to take it. So now we have to take a horseshoe magnet and we have to fix it. Now I will show you the diagrams also. So the diagrams exactly we have to draw, and we can indicating motion of the wire and everything. We can do it in our even lab also, so that we can notice definitely the deflections in galvanometer. So we can see. So now if you'll see all of you guys, this is what we used to call as the generating electricity with the help of a straight conductor is passing between the 2 poles of horseshoe magnet. And can you notice it here, everybody? So here you can see when the deflections is, might be noticed when the conductor is moved upwards. Have you seen, guys? So this is the direction of magnetism, always from North Pole to South Pole. Here also the direction of current, magnetism, North Pole to South Pole. Now you can see here the conductor is, the man is lifting the conductor up, next time down, next one time up, one time down, one time up and one time down, like that continuously. If you keep on moving continuously, you can observe the deflections in the galvanometer. So you might be notice it here. This is the dot point you will be see. That is what indicating, guys? Anybody can tell me, boys? The dot indicating what? 0 point. Understand? A 0 mark point in the galvanometer. So now if the conductor is moving up, you can see, guys, here, if the conductor is moving up, so that you can notice it, the current is moving in a clockwise direction, anti-clockwise direction. Current is moving in a anti-clockwise direction, so that the galvanometer deflecting towards the which side? Galvanometer is deflecting towards to the right side. All of you check it. So the current is passing anti-clockwise direction, like this it is passing, so that it is deflecting towards the right. Now when the conductor is lift up, now when the conductor is push it down, you can see the motion of the wire is downwards. Then you can see the current is passing what? Opposite direction. So by this time the current is passing clockwise direction, and the galvanometer, it is showing the which side it is deflecting. It is deflecting towards the left. But here they not mentioned right or left. Only they are saying opposite direction. You can see when the conductor is pushing up, then the galvanometer is deflecting towards the one direction, any direction, one direction. Then if you push it down, then the galvanometer is also will deflect into the opposite direction of the first is the first type of deflections. So this is what the experiment which we have to prove, that by current carrying straight conductor is moving between the horseshoe magnet, poles of a horseshoe magnet, then it is generating electricity. Can you notice it or not? Please speak here, all of you. Have you understand or not this one? So that is what. So this is the experiment to demonstrate electromagnetic induction. A current is induced in the wire when it is moved up or down between